See students, today the chemistry class number 15 I am going to take. The headlines is carbohydrates. Yesterday we have come across with the disaccharides. What are disaccharides? Disaccharides are nothing but the carbohydrates which contains how many monosaccharides? 2 monosaccharides. If it contains 3, trisaccharides. Okay. Yesterday I have given the definition for disaccharides. That is sucrose, maltose, lactose. Okay. Sucrose gives 2 monosaccharides, that is glucose and fructose. Maltose gives 2 monosaccharides, glucose and glucose, but lactose gives 2 monosaccharides, which is glucose and galactose. Okay. Hydrolysis of sucrose, maltose, lactose gives 2 monosaccharides. Therefore, all these are the that is the disaccharides. Next, coming to trisaccharide, you see trisaccharide. So trisaccharides are nothing but the carbohydrates which are hydrolysis gives 3 monosaccharide units. How many? 3 monosaccharides. So the example for this is raffinose. You see, I have taken raffinose as example. Raffinose. What is the formula for raffinose? That is C12H22O11. It is disaccharide. C6H12O6. It is monosaccharide. So if you get for raffinose, it is C18 and H. That is 34 minus 2 is 32. O 17 minus 1 is 60. Okay, so that is 34 minus 2 is 32. So plus you have to take 2H2O. You have to add 2H2O. It will undergo hydrolysis giving 3 monosaccharides. That is C6H12O6 one time, C6H12O6 second, plus C6H12O6. That is 3 monosaccharide units are formed: glucose, fructose, galactose. Glucose, fructose, and what? Galactose. So these are called the trisaccharides. Okay. So after that, you see, we are going to take polysaccharides. You see, polysaccharides. So poly means many. What is poly? Poly means many. That means you see, these polysaccharides are nothing but the carbohydrates which are hydrolysis gives how many monosaccharide units? Large number of monosaccharide units. Large number. It may be 100, 1000. Yeah, that is 200. Like that, you see. So for polysaccharides, what is the formula? That is C6H10O5 N times. So this is polysaccharide. Okay, it may be starch, cellulose, and glycogen. You see, all these are polysaccharides. Glycogen. So when these starch, cellulose, glycogen, that is polysaccharide, is subjected to hydrolysis NH2 I am going to put. So then you will get in, that is N times of C6H12O6. It is nothing but glucose molecules. That means you see, starch, cellulose and glycogen are called the polysaccharides. When subjected to hydrolysis, you will be getting large number of glucose units. Large number, N means what? Large number. So therefore you see, we come to the conclusion that polysaccharides are nothing but the carbohydrates which on hydrolysis gives large number of what? Monosaccharide units. So this is the example. Okay. And then, so this after this you see, we have one more topic which is called the reducing and non-reducing sugars. What is that? Reducing and non-reducing sugars. Reducing and non-reducing sugars. See here, reducing sugars are nothing but the carbohydrates or the sugars which reduces tolerance reagent into bright silver mirror and filling solution into red precipitate of cuprous oxide. What is that? Reducing sugars are nothing but the sugars which reduces which one? Tolerance reagent into that is bright silver mirror. Bright silver mirror and Felling's reagent, FEHLINDS. Felling's reagent into red PPP of cuprous oxide, that is U. So these sugars are called the reducing sugars. What are reducing sugars? The reducing sugars are those which reduces tolerance reagent into bright silver mirror and Felling's reagent into what? Red precipitate of cuprous oxide. Why? Because you see, they contains either aldehyde group or what? Ketone group. Which one? Reducing sugars, since they contains either aldehyde group, that is CHO, or ketone group CO, they reduces the tolerance reagent and what? Felling solution. So that is aldehyde group is called the hemiacetal, ketone group is called the hemiketal groups. Okay. So now coming to non-reducing sugars. For example, you see reducing sugars. Examples are monosaccharides like glucose, fructose, galactose. Monosaccharides like glucose, fructose, galactose. Disaccharides like maltose and lactose. Maltose, lactose, not sucrose. You should not give the example for sucrose. It is non-reducing sugar. So therefore you see all monosaccharides, disaccharides like maltose and lactose, and all polysaccharides are reducing sugars. Next, what are non-reducing sugars? Non-reducing sugars are nothing but the sugars which does not reduces water, Talens reagent into bright silver mirror, which does not reduces water, filling solution into red ppt of citrus oxide. That means you see Talens reagent, so that is non-reducing sugar should not reduces. That is the reducing sugar, non-reducing sugars does not reduce Talens reagent to bright silver mirror, and the filling reagent into red precipitate plus oxide, because non-reducing sugars does not contain either aldehyde group or what? Ketonic group. So for this reason you see, so they are called the non-reducing sugars. Example is only one, that is called the sucrose. So that is sucrose, you see, sucrose. Example for non-reducing sugar is what? Only sucrose. But for reducing all these, you see, all that is disaccharides, monosaccharides, everything is reducing sugars. Okay, that is the difference. So after that you see, we are coming to the that is monosaccharides again. That is monosaccharides first. That is monosaccharides. So monosaccharides definition you have already taken. So that is monosaccharides are nothing but the saccharides which on further hydrolysis does not use still that is still carbohydrates. You see, they are the simple unit carbohydrates which does not give still that is simpler carbohydrates on hydrolysis. Therefore called the monosaccharides, glucose, fructose and what? Galactose. Now in the monosaccharides, first one is glucose. You see, first one is what? Glucose. What is the formula for glucose? C6H12O6. Remember, this glucose is also called the grape sugar. It is also called the what? Grape sugar. Why it is called the grape sugar? You see, glucose is abundantly present in grapes. So glucose is abundantly present in what? Grapes. In the grapes, glucose is abundantly present. Therefore, it is called the grape sugar. And again, you see, this glucose contains an aldehyde group. Which group? Aldehyde group. So since it contains aldehyde group, so it is called the aldose. You see, aldose. And it contains 6 carbon atoms. Therefore, it is called the hexose. Aldohexose. You see. So glucose is an aldohexose. Glucose is what? Aldohexose. And it is a reducing sugar. It is a reducing sugar. Reducing. So that means it reduces Talens reagent at what? Bright silver mirror. And it is contains aldehyde group as well as 6 carbon atoms. Therefore, it is called the glucose is aldohexose and it is a reducing sugar. So that is the meaning of this monosaccharide glucose. Now you see, how do you prepare glucose? So preparation of glucose now. Preparation. So glucose can be prepared in 2 types. You see, in 2 methods. Let us say. So one method from sucrose. You see. What is sucrose? Sucrose means cane sugar. What is sucrose? Cane sugar. Cane sugar is also called what? Sucrose. Now, what is the formula for cane sugar? It is C12H22O11. Cane sugar. So this that is C12H22O11 cane sugar. It is subjected to hydrolysis, H2O hydrolysis. So then you will be getting in terms of dilute H2SO4 or HCl. You have to put dilute H2SO4 for HCl. So this will undergo hydrolysis, giving glucose and fructose. That is C6H12O6 plus C6H12O6. This is glucose. It is fructose. So that means you see, sucrose on hydrolysis gives glucose and fructose. So hydrolysis is carried out by dilute sulfuric acid, what? Dilute HCl. It is first method. Second method you see, from starch. You know that the starch is a polysaccharide. What is a starch? Starch is a polysaccharide, and it is present in the starchy substances like potatoes. Potatoes contains much of starch. Okay, if you remove the layer on the potato, everything is starch pulp. Okay, so there this is formula C6H10O5. N times you see, this is starch. This starch undergoes hydrolysis. You see, NH2O. So it gives rise to in presence of that is dilute H2SO4. It is heated to 333 Kelvin and a temperature of 2 to 3 atm BC. So these are the conditions you have to satisfy. So therefore starch undergoes hydrolysis in terms of dilute sulfuric acid at 3 Kelvin, 2 to 3 atmospheric pressure. So giving only glucose molecules NC6H12O6. That means C6H12O5 starch undergoes hydrolysis giving glucose, only glucose molecules, not others. Starch gives only what? Glucose molecules. So but it is commercial method, you see. Starch from that is commercial method. It is a commercial method. Commercially, that is glucose is prepared by starch. So starch is taken to be commercial method for glucose, you see. Okay. These are the two methods for which that is glucose can be prepared. Of course. Now you see, after the preparation of glucose, we have to know something about the structure of glucose, you see. What is that? Structure. That is called the elucidation structure. Elucidation structure of glucose. Elucidation structure of what? Glucose. How do you perform the structure of glucose, you see? We know that, you see, glucose contains there is 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So that means, you see, elucidation structure of glucose can be explained on the basis of several factors, you see, different factors. Following factors, let us say. That is number 1. First one. So molecular formula. So how do you get this molecular formula? Molecular formula of glucose seems to be C6H12O6. That means, you see, by the how actually the C6H12O6 is obtained, you see, by the percentage composition and molecular mass determination. In the first year PhD we have learned how the molecular formula and empirical formula can be calculated. Empirical formula and molecular formula can be calculated. So therefore, you see, here the molecular formula of glucose is obtained by the percentage composition and molecular mass determination. Okay, percentage composition, molecular mass determination found that it gives that, you see, the molecular formula of glucose is found to be C6H12O6. By this, we know the molecular formula like C6H12O6. So that is first one. So next, second one. So that is glucose contains that is long, unbranched 6 carbon chain. That means, you see, for example, so that is long 6 carbon unbranched chain, let us say. Unbranched chain. I am going to write like this. So that is second one. Glucose contains long 6 carbon unbranched chain. How actually it can be explained? So that means glucose molecular formula is H12O6. So that is second one is presence of long 6 carbon unbranched chain. It contains 6 carbons, but there is no branching long chain. How do you show that, you see? It can be written like this, you see. That is CHO, single bond CHOH 4 times, single bond CH2OH. It is called as the glucose, you see. That is C6H12O6 can be written like this. Ready? See here. 4 times of carbon, 5, 6, C6H, 4, 4, 8, plus 1, 9, 10, plus 2, 12. Oxygen atoms, 4, plus 1, plus 1, 6. So this is how the glucose can be written like this, you see, CHO, CHOH, 4 times, CH2OH. Okay, this is glucose. When this glucose is heated with hydrogen iodide, heated with what? Hydrogen iodide. So it undergoes reduction. Reduction. So giving N-hexane. What is the formula for N-hexane? That is CH3, single bond CH2, single bond CH2, single bond CH2, single bond CH2, single bond CH3. 1, 2, 3, 4, 5, 6. Plus 6H2O you have to write. Plus 6H2O. So that means, you see, when glucose is heated with the hydrogen iodide, it undergoes reduction. So giving that is N-hexane. How actually what I can see here, you see here. Let me write hydrogen iodide here, you see, reduction with hydrogen iodide. Okay. So now you see, when it is heated with hydrogen iodide, we are going to get that is hydrogen atoms, you see, H. So I am going to take 14 H. How many hydrogen atoms? 14 hydrogen atoms I am going to take from this HI, you see. So therefore, out of 14 hydrogen atoms, so here you see how many hydrogen atoms are there? Here how many? 12. 12 plus 2, how much? 14. So that is NHN is nothing but C6H14, you see. Remember, it is C6H14. 1, 2, 3, 4, 5, 6, C6. H. 3 plus 2, 5. 7, 9. There is 11 plus 3, 14. Okay. And remaining 12 hydrogen atoms are there, basically. So the 12 hydrogen atoms react with the 6 carbon atoms, giving a 6H2O. 6 2s are 14 plus 6O. So this is how. So glucose contains long 6 carbon unbranched chain. You see. So this is a long unbranched. There is no branching here. So this can be. That means you see. How do you show that glucose contains 6 carbon unbranched chain? 6 carbon unbranched chain. So it can be explained like this. You see. When glucose is heated with there is a hydrogen ion, it undergoes reduction, giving N-hexane, which does not contain any branching. Therefore, this reaction indicates that you see carbon contains 6 carbon unbranched, long 6 carbon unbranched chain. So this is second factor. So next, I am going to take the third factor. You see, how do you perform the structure for glucose? Number 3, that is presence of. So that is aldehyde group, terminal aldehyde group. Let us say terminal aldehyde group. Terminal aldehyde. What is which is the aldehyde group? Can you tell me the aldehyde group? CHO. What is the aldehyde group? CHO. So here you see. So this aldehyde group is also present in our glucose. How do you show that? It can be shown that like this, you see. So there is CHO, single bond CHOH 4 times, single bond CH2OH. So 6 factors are there, you see. So we will complete. Let us complete all the 6 factors again. So therefore you see presence of terminal aldehyde group. That means it is found that you see aldehyde group is present at the last end of the glucose molecule. You see CHO here, CHO, CHOH 4 times CH2OH. So this is glucose. So how do you show that this CHO is present? It can be explained by the oxidation reaction. Which reaction? Oxidation. Let me write. So oxidation with bromine water. You see Br to H2O. Br to what? H2O. So it will use nascent oxygen atom. Which one? Br to H2O will use nascent oxygen. So therefore you see this CHO group will undergo oxidation. Which group undergoes oxidation? CHO. CHO undergoes oxidation giving COOH. COOH. Here COOH. COOH. In between CH you have to write 2 oxygen atoms. You see COOH. In between C and H you have to write oxygen atoms. You will be getting gluconic acid. What is that? Gluconic acid. So remaining is right as it is CHOH 4 times. So single bond CH2OH. So this compound is called the gluconic acid. What is this? Gluconic acid. That means you see glucose undergoes oxidation giving gluconic acid such that aldehyde group is oxidized to carboxylic group. So this indicates that you see. So glucose contains terminal means end. Okay, at the end you have aldehyde group. So it is undergoes oxidation to carboxylic. This reaction indicates that glucose contains which group? Aldehyde group. Okay. So next it is third one. Next coming to fourth one, you see. So fourth one is presence of that is a carbonyl group. Presence of carbonyl group. Which is the carbonyl group? CO. Which is the carbonyl group? CO group is called the carbonyl group. Okay. So how do you show this carbonyl group is present in the glucose? It can be explained by 2 reactions. You see. It can be explained by how many reactions? 2 reactions. So one reaction. Let me write the one reaction here. It is okay. So here CHO. Here CH double bond O. Then CHOH 4 times. Single bond CH2OH. Cl. Glucose. Or otherwise I will write here. Okay. So it is better to write here only. So that is 4th factor I am going to explain. So presence of there is carbonyl group, you see, presence of carbonyl group. So let me write here, you see, that is CO, that is CHO. So CHO can be written as CHO, single bond CHOH 4 times. So this is CHOH. It is glucose, you know. So this is glucose. Now, where this carbonyl group is present? CO. This is CO. This group is called as CO. Now, it is made to react with one reaction. It is made to react with hydroxylamine, NH2OH. NH2OH. It is called as hydroxylamine. Hydroxylamine. So this hydroxylamine when it is heated, you see here. So this oxygen atom and water H2 will be removed as water molecule. H2O. Here H2O. It is removed as H2O, and you will be getting, so that is glucose oxide, you see. Glucose oxide. Glucose oxide. So that means you will be getting C double bond N single bond OH. So this is hydrogen atom. This is CHOH 4 times. Single bond CHOH. So that means you see this reaction indicates the presence of carbonyl group, you see. This group is called the carbonyl group. So that means you see when glucose reacts with hydroxylamine, you will be getting glucose oxide. What is that? Glucose oxide. Glucose oxide. And this is one reaction. Another reaction, you see, let me write another reaction also here. So that is CHO, that is CH double bond O, that is CHOH 4 times, and CH2OH. This is glucose. When it is made to react with that is hydrogen cyanide, you see. One more reaction, addition reaction, hydrogen cyanide. So and then you will be getting, you see, so addition reaction takes place in such a way that you see, so hydrogen atom is added to this oxygen atom, will be getting OH, and Cn will be added here, you see, here. So then you will be getting addition product, that is CH. So this is OH, this is Cn, and this is CHOH 4 times, CHOH 4 times, and CH2OH. So this compound is called as that is glucose cyanohydrin. Glucose cyano, CYANO, cyanohydrin. That means glucose reacts with hydrogen cyanide, giving glucose cyanohydrin. So therefore, you see, it also the reaction which takes place with the carbonyl group. This is also carbonyl group. These two reactions indicates that you see glucose contains which group? Carbonyl group. Okay, we will continue.